Barbara, min nærmeste kollega, vil lave præsentationen, and this presentation will happen in English. I'm sure it will be no problem to you, and it will ease my colleagues' work a lot. So please, Barbara.
I think it will be easier for you if I speak English than if I would have to speak Danish. It's not because I don't speak Danish at all, but well, that's easier. So I will go to small scale, as Lars just said, and tell a little bit about breakout experiment that we conducted in our climate chambers. I will not go deep into these slides since everything has been said. We have three types of sources of PCB in the buildings. The primary source, which is relatively easy to remove, but it doesn't help, as it was said. Then we have the secondary sources, the sources into which PCB migrated directly from the primary source. And then both primary and secondary sources, they emit to the air. And because of low vapor pressure and high octanol to air partition coefficient, PCB has tendency to reabsorb into surfaces, and this is how the tertiary sources are created. And of course, it is a big question mark what we should do about the secondary and tertiary sources, and this is also what we have focused on in this small laboratory experiment. So the objective was to study the effect of temperature on the PCB remediation from the secondary and tertiary sources. And for the purpose of this experiment, we decided to increase temperature from, what does this look? Yeah, from 23 to 40 degrees Celsius. And as you can see on this graph, by this increase in temperature, we increased the vapor pressure by a factor of 12. What it means? It means that we speed up the process of evaporation from 1 year to 1 month. And the question was how this process will influence indoor concentrations, whether we can really make the difference. We conducted the experiments here at SBE in our laboratory facilities. We have small chambers called CLIMPAC, chamber for laboratory investigation of materials, pollution, and air quality. Those small chambers are placed in a big glass chamber, which is ventilated with conditioned air. Those chambers has a volume of 51 liters, and they can be ventilated with a maximum airflow of 6.5 cubic meters per hour, which corresponds to 127 air changes per hour. And the air we ventilated the chamber with can be conditioned between 10 and 40 degrees Celsius and 30 and 70% of relative humidity. As Annette already said, we got block of concrete from a school in Odense, and before we got this block, the sealant has been removed. So there is an empty place after the sealant. This block was placed in one of our small chambers and was ventilated with 0.18 cubic meters per hour of fresh air. And this corresponds to 0.5 air change per hour if we assume that a room was made, that all walls, ceiling, and floors in a room were made of such concrete. This, of course, creates a very worst case scenario. So we expected, of course, to measure high concentrations. We measured the 7 typical PCB congeners, 28, 52, 101, 118, 38, 53, and 180. And we measured at baseline, that means at 23 degrees Celsius before we increased the temperature to 40 degrees, and then after we increased the temperature to 40 degrees after 1 day, 2 days, and so on for over a month. After 36 days, the temperature was set back to 23 degrees, and the measurements we took was after 2, 9, and 30 days. The next slide shows results for the baseline measurements for 23 degrees before change to 40. What you can see, of course, is that the high vapor pressure PCBs were at higher concentrations than the low vapor pressure PCBs. But what is important is that the total PCB calculated as a sum of those 7 multiplied by 5 was almost 6 times higher than the 3,000 nanogram per cubic meter. This slide shows results from the whole investigation. This is the measurements at baseline. This is a PCB concentration in the air and nanogram per cubic meters, and the different lines corresponds to different congeners. This is the measurements at baseline at 23 degrees. Then the temperature was changed to 40, and then it was set back to 23 degrees. So as you can see, change in the temperature was followed by a huge increase and immediate increase in a PCB concentration, which then had tendency to stabilize and even decay a little bit. But what had happened at the end of this high temperature measurement, we saw the high peak in concentration, which we cannot really explain. The pity about it was that it is not online measurements, as you know, so we didn't know that such a peak happened when we decided to decrease the temperature back to 23 degrees. Otherwise, we would continue here to see what happened. So what are the conclusions and some next steps following this experiment? We plan to continue this experiment in order to investigate the nature of the last peak. I mean, as I said, we don't have the explanation right now, but of course it could have been analytical mistake. However, because this 1 month follow-up, I mean, the concentrations are pretty stable here, so I do not really believe in the analytical mistake. But it could also happen that the diffusion of PCB into the block is not really continuous and uniform process, and there are some areas in the block with higher concentration, and after this almost 40 days we have reached those areas. It could also happen that there was some kind of primary source still inside the block, which we reached after the high temperature period. This we need to further investigate. So as I said, no conclusion about it yet. Then, even if we assume that the peak was not here, I mean, there was not much decay, so in this, with this experiment, we cannot really confirm the positive effect of the bake-out. But as I said, the concentrations were really high. It was only the secondary sources, so at the same time, we do not deny that bake-out could help with the tertiary sources. But we need more experiments about it, both in a field and in laboratory as well, and this is what we are planning to do. So this is all I prepared for today. Thank you very much.
You measured concentration of PCB at the surface of the concrete?
No, we haven't measured, but you have done some measurements in the concrete, right? Not in the block, but in the concrete.
There were some measurements before we started about 25 millimeters and 40 and 60 millimeters, and I think it was about 22 milligrams per kilo, something like that.
It was inside the concrete, it was not at the surface?
Yeah, exactly. Okay. The distance of 2.9 centimeters.
Yeah.
I don't remember the exact, but something like that.
Yeah, so thank you, Barbara.